This lesson is going to talk about triangle similarity and congruence. We're going to start with similarity. So similarity triangles have the same shape, but not necessarily the same size. So they can have corresponding angles that are congruent and sides that are proportional. So when we have a angle, that doesn't necessarily prove that the triangles are congruent. It does prove that they're similar. We have to prove congruency by the corresponding sides. And so we're going to write first down that definition. And then we're going to talk about the 3 ways to tell whether 2 triangles are similar. So make sure you understand what similar triangles are. Same shape, but not necessarily the same size. And corresponding angles are congruent and the sides are proportional. So there's 3 ways to tell if 2 triangles are similar. We have the AA triangle similarity theorem, where 2 corresponding angles are congruent. Well, obviously if 2 are congruent, then the other one's going to be congruent, because we know that a triangle only has 180 degrees. So then therefore that they are similar triangles. You have the SAS, where 2 corresponding sides are proportional and the included angle between them is also congruent. Then you have the SSS triangle similarity, where all the sides are proportional. So we're going to look at some common ways to prove that triangles are similar with some methods, and we'll talk about our transversals and some properties. So there's some angles marked here, and we can see this is 2 parallel lines cut by a transversal. And if we look at this angle here, I'm going to mark it, and this angle here, we kind of have a Z pattern, and they're on either side. And they're inside the parallel lines. These are alternate interior angles, and that's a way that we can show similarity. So alternate interior angles. Now, if we have them where one's on the outside of the parallel line, touching the transversal, so we have one kind of here, and then we have another one that is in the same exact area on the same side, touching the same transversal, but it's inside. These are called corresponding. So think about if we picked up the bottom section and set it on top of the other one, these are corresponding angles, and that's another way to prove similarity. And then we have here, we have an angle here and the angle here, and they're across from each other. One's on the inside, one's on the outside, but they're opposite. These are vertical angles. And then here we have a triangle that has been kind of overlapped with another. So we can think about, let's make this a little smaller here. Alright, so let's think about this triangle here, this big triangle. And then we also have a smaller triangle here on top. We don't know anything about their sides, but we know that they share this angle. So this is what we can call reflexive property with same angles. These are the same angles. All right, so they share that. Where the next one we have, I've drawn a line down the middle, they share a side. And so if they share the side, this point, if we call this A and we call this B, A is B and B to A is A to B, same difference. So this is called reflexive property, but with the same side. Okay, so these are some of the common concepts that we help prove that triangles are similar. So we look at the numbers 1 through 5 here, and we can see some that are similarity and some that are not. So on the first one, they're not similar. We do both share a 60, but then we were given a 62 in this first one and a 54 in the other one. So for them to be similar, if I would add these to 70 or 62 and 60, I got 122. And if I take it away from 180, which we know every triangle is, I get 58. For them to be similar, this would have to be 54, and it's not. So they're not similar because there's no 2 angles that are congruent. On the next one, we have a 50 and we have a 50. Great, that's one angle. Then we have a 60 here. We add these two together, subtract from 180, we get 70, and we have a 70 here. So immediately we know that these are similar because of angle. So they have two angles that they share that are congruent. On the next one, we have an angle. This right triangle, the right little angle box tells us those are 90 degrees. There's two angles. And then these are vertical from each other. So we know we have those are similar by angle similarity. That little similarity sign. I don't know what happened to number 4 here with this one. It's a little crazy, but I had an angle that was the same, the 75 degrees. I wasn't given anything else for angles, so I had to look at sides, and I'm given some here. So if I look up and set up proportions, I can see that 15 over 10 corresponds to YX or XY, and then the AB is simplified down to 3/2 and is same as the other side that corresponds. 21 over 14 simplifies to 3/2. So this is similar triangles by side, angle, side, and the angles in between those, and so it's similarity by that. And the last one, we have all sides, and if you think about what's proportional, we look at A, B, C, and then we have to go in order, X, Y, Z. That helps you kind of know what is congruent. So A to B is congruent to X, Y. That's why I set up 4 over 5. Always make sure you're setting up the first one you're talking about over the old one or vice versa, but be consistent. And they all simplify proportionally down to 4/5. So therefore they are similar by side, side, side triangle similarity theorem. We're told that these triangles are similar, and we're going to state the 3 similarity ratios. So we have JKL and UVW. I like to stack mine just to make sure that I keep things in the same line. So if I start with JK can be similar to what it's on top of is UV. I also can look at KL, which is the next little section there, KL, and what it's stacked on is VW. And I need to have one more piece, and so I look at the very first one, and I can do an LJ, and I'd have to do WU, and that's fine. Or I can do JL, because it hasn't been put with L yet, over UW. So order matters when you're writing these. Now with the second set, we can look at our congruent or similar angles to help us. So we can see that we have a 50, this is congruent, and we have a 60 and a 70. But if we add these two together, 70 and 50, and then subtract it from 180, we see that this is also 60. So this will give it 2 little arcs, and then the 70 we know has to be here, and then that helps us with our congruency and knowing the corresponding sides. So if we look here at 70 to 60, this section right here, and we look here at 70 to 60, we can see that C corresponds to F. And then we look at the 60 to 50, and that's A, and that on the other ones corresponds to E. So A over E. And then our last would be B over D. So those are our ratios for those two triangles. Now we're going to move into proving whether or not something is similar. All right, for this first one, we're trying to prove that triangle EFG is similar to IHG, and H has kind of been knocked off there. So we are told that EF, so side EF here, and IH here are parallel. So these are parallel to each other. So now we can write that in our 2-column statement as given, and now we've got to find some other things we're trying to prove similarity. So the first thing I see that we can prove is the angle here. If we know that they're parallel, we can look at this line here, and we can think about that as a transversal. We can also look at the other line here and think about it as a transversal. So let's focus first on the yellow one. So looking at this first transversal, we can tell that because it's transversal, this angle here and this angle here, so we think about this touches a parallel and the transversal and a parallel. It almost makes that Z-shaped here, those are alternate interior angles. Okay, so that can be our next statement. Number 2, we have the angle, and we need to make sure we're saying it correctly. Angle E, right here. Angle E is congruent to angle I. And the reason being is it's alternate interior angles. All right, so let's look at another thing we need to be able to prove, because we're trying to prove that the triangle EFG and IHG are similar. So when we look here, if we can kind of highlight what we're doing here, we're trying to find EFG, this triangle here, and the triangle IHG. So we're trying to make these two angles prove that they're similar. So we have to think about our similarity rules or reasoning. So we've got an angle. We've got something that is parallel, so that helped us know that those were transversals. So now we got to find some other angle or some other side or something to help us. So we can see another transversal here. If we look here, this from H to F is a transversal. We could write that for one of our statements that HF is a transversal based on transversal definition. I'm not going to. I'm going to skip that and just go straight to what it is. But that makes this angle F congruent to angle H. So for number 3, angle F is congruent to angle H. And that is also because of alternate interior angles. Now, we have two angles, and we're just proving similarity. We don't have to go further. We could look at the vertical angles that are created right there at the intersection point. But we're just going to talk about either AA, triangle similarity, SAS, so side, angle, side, and side, side, side. Well, we already have two angles, so obviously we're going to use angle, angle. So we can say now, for our last part, that for number 4, triangle EFG is similar to triangle IHG, and the reason being is because of angle similarity. All right, I want you to try the next 2 and see how you do. And here are your responses for numbers 2 and 3 with similarities. All right, for number 4, we want to prove that triangle OPQ is similar to QRS. And we're going to start with our given statements. And we're given that OP is parallel to QR. So when we think about OP, we have a piece here. It's parallel, so parallel to QR. We can mark that, and we'll write that as a given statement. So OP parallel to QR, and this is given. And then our second statement is PQ is parallel to RS, and that is also given. And we'll go ahead and label those as well. So PQ, and put 2 little lines there, and RS are also parallel. So then we can look at what we see, and we notice that we have another line here, this S to O, and we can think about kind of what is happening here and our relationship. So we can kind of look at this triangle here versus the triangle here, because that's what we're trying to prove. And so we're trying to prove similarity. So right now we have some parallel sides, but we can kind of think about this long line here, S to O, as kind of like a transversal. If we would extend this parallel line out and this parallel line out, it's actually cutting a transversal. And so we can think about that as a transversal, which gives us a relationship of some angles. So it tells us that the angle here, the S angle, do a different color here. the angle of S and the angle of the Q here are the same. Okay, so we can kind of think about that because of our corresponding. So, and then we can also look here at the top angle, so the angle here, and then the angle here as corresponding as well. So let's go ahead and write those. It doesn't really matter what order. So we'll do 3 as angle, we'll do angle S first. So we write that one first. Angle S is congruent to angle, and we need to call that one specifically OQP. And then the 4 will have angle O is congruent to angle SQR, and both of these are corresponding angles. We'll just put 0 there. All right, so now we have a couple things. We have 2 angles in here, and then we're just proving similarity. So now we know enough to go ahead and write our similarity statement. So 5, we'll consider triangle OPQ is similar to triangle QRS. And the reason being is our AA similarity. All right, I want you to try 5 and see how you do. And check out your number 5 and see how you did. All right, for number 6 through 9, you're actually going to solve for variables using similarity rules. So they're telling you, for example, number 6, that triangle ABC is similar to DEF. Again, you can use the stack method of ABC, DEF to help you with your ratios. So we're going to go ahead and use what we know. So A to B, so if we look from A to B, we have 20. And A to C is what we don't know. We need an X. So A to C would be the same thing as D to F. So if we think about what's familiar, we can write your 3 ratios. You have your A to B over the D to E. You have your B to C over E to F. And then you also have your AC over DF. So you can kind of write those out to kind of help you make your ratios. So we have to find X and we have to find Y. So we know we're looking for 2 unknowns. So we've got to set up some situations so that we can find those. So if we're looking for A to C, which was where our X is, we can use this piece here. So A to C is going to be X over D to F, which is 12. And then we can set it up with another piece that is known. We obviously don't want to use E to F because we don't know what Y is, so we'll compare it to AB, which we know is 20, over DE, which is 15. Now, from there, we can do cross multiplication and solve. And the same way could work for our Y value, and we would set them up. So when you go ahead and pause, try to work it, and then see what you get. So with these two, we got X equals 16 and Y equals 10.8. Notice that I used the 20 over 15 for both of them because I knew that was a true fact instead of using something that I find and then plugging back in case I made a mistake. All right, so I want you to try 7 through 9 and see if you get the right answers, and then check yourself. And you can see what we got for 7, 8, and 9. Check your work and see how you did. Now we're going to move on to triangle congruence and review how to set up a 2-column proof. All right, so we've been talking a little bit about 2-column proofs already, and you've done a few, you've done them last year. So just to refresh, when you're starting with a 2-column proof, your first section is your statements. Those are your what you're trying to prove and or what you've been told. So you may be giving 1, 2, or more given statements. So your first, maybe second, possibly third are going to be statements that you are listing individually, and those are your givens. Okay, so you'll have those written as given. And then you look at your body, and that uses any first thing. So, for example, properties, anything that you first need to prove before you move on to something else. So your givens come first, and then your properties, theorems, postulates, and definitions are facts that can prove other things. So we are thinking about, and this could be a multitude of pieces, but we'll just call it 3 for the whole. And this is what you can prove. And you can't just prove it by just saying, oh yeah, because I think so. You have to use these properties, theorems, postulates, or definitions. And the reason is the why. So those would be a such and such theorem, a such and such definition, whatever it may be. And then the conclusion is what you're trying to prove, what the problem is asking you to prove. So the fourth thing would be what your prove says. And that is always going to also be what drew you to that conclusion. So, of course, after you prove a triangle, you can use CPC-TC, or you can use a definition depending on what situation you're going into. So there are a couple ways triangles can be congruent. So we talked about this briefly. So we know that we have side, side, side. We have side, angle, side. You have angle, side, angle. You have angle, angle, side. Now, we talked about angle, angle, angle before, but that doesn't necessarily mean that they're congruent. That can just prove that they're similar. We have to be a little bit cautious with that. And we also have hypotenuse leg. Now, this looks like the side angle, but it has a right angle. So this one has a right angle, but can look like side angle. So that's important to remember. You have to have a right angle for this, opposite of your hypotenuse and one side. Okay, so you need right angles, and you need it has to be across from your hypotenuse, your longest side, and one side. Now, some key things to remember is that each step is important. Don't assume. And don't skip. So if you need it to prove something, you can't just think somebody's going to know, or just skip a step and just be like, oh, you should have known. You have to prove it. That's all about proof. And if you can't explain it, meaning it doesn't have a why. So if you can't explain the why, you can't use it. So that's why it's important to know your properties and your theorems, your postulates, and your definitions, because you need to be able to explain the why for things so that you can use to know why things are similar or congruent. So these examples here are the most common concepts to help prove triangle congruence. So we have the reflexive property, BD, so we have the same line basically. Obviously BD is congruent to BD. Sometimes we'll say BD is congruent to DB. You might hear that as symmetry, but when it's the same line, we use reflective. And so those are congruent. And then we have vertical angle theorem. If I mark A and E, then you know what's corresponding. So triangle or angle ACB is congruent to angle ECD. Then you have the midpoint definition. So it's telling us that point C here is the middle of AE. So if it's the middle of these 2 points, then it sets the two pieces CE and E or AC is exactly the same. So they are exactly congruent. So that's the midpoint definition. Then you have an angle bisector. A bisector breaks an angle right into half. And this one says that AC here is breaking apart or bisecting BCD, which makes these two angles congruent. And then we can say the angle BCA is congruent to DCA, so the angle bisector theorem. And then we have perpendicular lines definition. It tells us that AB here is going perpendicular to CD my D's off a little bit, so I wrote it. So CD. So that makes those angles right angles. And so that, by definition, gives us perpendicular lines. So a right triangle definition is that these two triangles, the ADC, so each side, and BDC, are right triangles by definition of right triangles. And then the theorem is that the angle ADC and the angle BDC are right angles by the right angle theorem. So let's look at some what ifs. So this one here, you'll need to mark. We have A, C, B, and D. And we are told some things that are given. So AB is perpendicular to DC, and so it's showing that you write that, and that would be given. So that would be our number one. And then to help us prove that ADC, so we're trying to prove triangle ADC is congruent to the BDC triangle. What we would use is we could say that angle ACD, which would be this angle here, and BCD, this angle here, are 90 degrees or right angles because of the definition of perpendicular lines. So this could be 2 and 2. And then our next steps depend on what we're trying to prove. So if we're trying to prove triangles, or trying to prove a certain angle, it could be different, okay? So it just depends. If we're trying to prove SAS, so side angle side, or angle angle side, or angle side angle, we would need to look for our angles of ACD being congruent to angle BCD, and that would be the right angle theorem. That would be the Y. Just abbreviate that. So if we're trying to prove one of those things, because we already have one angle, and if we were trying to prove another angle, or if we're trying to just prove those angles, that's the right angle theorem. However, if we're trying to prove hypotenuse leg, or we use hypotenuse leg to prove, we've got enough information for that, then we would say that triangle ACD and triangle BCD are right triangles by definition of right triangles. So by definition of right triangles. All right, for this next section and the rest of the booklet, you're going to be doing two-column proofs and proving if it is possible to prove, and if not, you state why. So we'll do the first one together. So we're going to do our first given statement. We're given AB, and these are not marked. You'll have to mark them as you go, as you watch the video. So A, B, C, D. So AB is congruent to CD, and that is given. So we'll mark those. AB congruent to CD. Go ahead and put one on mark. And 2, angle CAD. So CAD, which means we have to have a diagonal between there to get angle CAD. So we'll go ahead and put that there. So CAD, this angle right here, is congruent to angle ACB. So ACB, and they are given. And then we've got to think about what else we know. So right now we know angle, and we know a side, and we're trying to prove that ABC, this whole side triangle here, is congruent to CDA. So we need to look at what else we can prove. We can prove that AC, so it's a different color here. We can say that AC is congruent to CA with reflexive property. So we could mark this here. So if we're looking now at A, B, C, we have a side, an angle, and we have another side, but it doesn't touch each other. So we're given here, we have a side here, we have an angle here, and we have a side here. But we don't have any right angles. So we can't say, because these are not touching, if we have this side, we could say side angle side, but our side is separated. So there's actually not enough information to solve this one. So this one is not congruent. And so we have a side-side angle, but no right angles to be able to prove that. So that one will not work. So you're going to work the rest of them, and I'll go ahead and give you the labels for this page. And then as you progress through the video and answers, because I don't do a whole lot of explaining from this point on, just the answers you'll be able to mark down. So this one is A, B, C, D. This one here is A, B, C, and D is here. And then the bottom one is A, B, C, D, and E here. All right, go ahead and work through them. Pause as you go and then check your answers to see if you're right. You can take a quick look at the letters, pause, and then continue working. Here are your answers for number 2, 3, and 4. Remember that you cannot have a hypotenuse leg unless you actually know hypotenuse, a right angle, and another side. So for number 3, we couldn't have hypotenuse leg for proving, even though we have a right angle. We do not know the hypotenuse, which we know is always diagonally across from the right angle. And in this case, we do not have anything proving that they are congruent or their values are not given. So this would not be hypotenuse leg. Then for number 4, your final answer, when we think about after it's vertical, we have here, we can say our triangle ABE is congruent to triangle DBC, and the reason being we have an angle. So if we think about ABE, we have an angle, we have a side, and we have an angle, and the side is stuck between the two angles. So for that reason, it's an angle side angle, where if the angle is stuck between the two sides, it's a side angle side, like for number 3. Number 5, your marks, make sure you had your angles ACB and then EDF, and then work those out. Number 6, and then number 7. Here are your work problems for number 8, 9, and 10, approving congruent triangles. Here are your labels for 11, 12, and 13. And then your answers, 11, 12, and 13. Your last two, number 14, your labels, and 15 should have your labels. And then your answers for 14. This one we can do hypotenuse leg because we do know the hypotenuse, we know another side, and we know the right angle. So therefore it will be a hypotenuse leg. And then for 15, there are your answers.